Hello, dear students. This is a short video on the exam coverage document which we have for grade 9 advanced physics. Okay, so we have an exam coverage which is good, so we can know the topics which will be asked during the exam. So, as is mentioned here, there are like 15 multiple choice questions, and there could be like four marks each for each of the multiple choice questions, and you could have like four free response questions. That means free response question means writing questions. Okay, so let us discuss what could be the kind of questions that could come in this exam coverage. So let us have a look at it one by one. I will go through the learning outcome and performance criteria. So the first one is explain Kepler's second law, which states that an imaginary line from the sun to a planet sweeps out equal areas in equal intervals of time. Okay, so this is one of Kepler's law, the Kepler's second law. So in the Kepler's second law, what they could ask is basically they could give you a picture of a planet or a satellite going around a planet, or the planet going around the sun, whichever it be. So they could ask, like they could show a shaded region of the planet going around in 1 month. It is sweeping some, the imaginary line between the sun and the planet is sweeping some line and some area, and maybe after few months it again sweeps another 1 month of area. So the kind of question that could come is where will the planet be faster, the orbital velocity be faster. Okay, so when the planet is closer to the sun, it will be faster. When it is far away from the sun, it will be slower. Okay, so that's what the crux of this learning objective is. Or they could ask something like they could give a list of statements on the different kinds of alternatives, and they could ask which of this is the Kepler second law. So you have to read the statement correctly and answer which of the statements correspond to the correct Kepler's second law. So this is one. These are two possible questions I can think of. Then another kind of question is, let's look at the second one. Second question: explain the law of universal gravitation and write in equation form. So you see, they could what they could do is, first of all, like in the new law of gravitation, the force of gravity is proportional to the product of masses and indirectly proportional to the distance between the masses, square of the distance between the masses. So they could ask about this proportionality. Okay, so they could ask, give a list of options wherein they could ask like what is the uh, proportionality sign for like for masses and for the distance between the masses. So is it inversely proportional, is it directly proportional? Or they could do another kind of trick. They could ask, they could say like they have doubled both the masses, or they will say they have doubled the distance between the masses. So what will happen to the gravitational force? They could double or triple or quadruple the masses or the distance between the masses, and they could ask which what happens to the force. Does the force double, or does the force become half accordingly? So this is another kind of question that can be asked. Or they could just ask directly a statement. What is this? You have to select the correct statement about the universal law of gravitation. So that's the second one. Then the third one, you have to calculate the orbital period of the satellite. Now, orbital period of the satellite can be calculated two ways. Okay, so depending on the question, you should read the question carefully and figure out which would be best for you to answer in. So, one way to calculate the orbital period of satellite is using the direct formula for the orbital period. which combines the universal law of gravitation and the Kepler's third law. Okay, and another then another kind of calculation would be the ratios, like the t square, the period of time period t square is proportional to r cube, the radius of the orbit of the satellite. So this is another way. So in the second method, which you can use, you will be given the radius of two satellites which are orbiting the Earth or maybe some other planet, and they could give you the time period of one of the satellites, and you may have to find the unknown, the period of the satellite which is not given, the time period is not given. So that is the third kind of the second kind of possibility to ask. So you can find out by reading the question. You have to list down the knowns and unknowns in your rough work, and you have to figure out which one is useful. Now the direct formula for orbital period you can use. You can use if the mass of the planet or the Earth is given, then you have to use the direct formula. If that is not given, then you will use Kepler's third law. Okay, so that's what we have to learn in this one. The fourth one, you can see that it's asked explain Kepler's first law, Kepler's first law, which states that the planets follow elliptical paths with the sun at one focus, right? So in this one they could give you, I can think of it as a multiple choice question. They can give you a list of sentences which you should read very very carefully to really select the option in which the right law is mentioned, right? Kepler's first law, it says that the planets follow elliptical orbit and the sun is at one of the focus. So you have to read the statement and correctly select the correct option. So that's one kind of question they could ask. Uh, then another one is about defining gravitational force as force of attraction between two objects of given mass. So this is again another question regarding gravitational force. So the gravitational force is attractive, it is between two masses, and it is directly proportional to the product of the masses. So they could ask something in that line. So it could be a multiple choice question. Okay, then you have the sixth learning objective, which is identify work as a scalar quantity measured in Newton meter or joules. Okay, so what kind of question can this be? Basically, they could give you a set of units. Okay, the unit of work is joule, but 1 joule is also equal to 1 Newton meter, right? The Newton meter is the derived unit for the uh, work done. So they could ask you which of the following units correspond to the unit of work. So that is one way of doing. Then another thing is they could give a simple problem like force is acting on an object and it moved by so much meters. This is the force in Newton, so you have to find what is the work done. So this is a very straightforward question they could ask. And another kind of question is question number 7, like in our exam coverage, which is illustrate when work is positive, negative, or zero. Okay, so first of all, let us discuss with when is the work done zero. Work done is zero when the force and the displacement or the direction of motion of the force when they are in perpendicular to each other. So in this, for example, they can give you a planet going around the sun. Okay, assuming that they can give you a picture of a planet going around the sun in a circular orbit. So you know that in a circle, the radius of the circle and the tangent to the circle is are always perpendicular. Okay, so a planet, when it moves in the tangential direction, right? So always the radius is perpendicular to the tangent. So that's the kind of question that can happen. So if they can give you a picture and say, okay, tell me whether the work done, what is the work done by the sun in moving the planet around it. So the answer is zero, because the radius and the direction of motion of the planet are perpendicular. Then another case is when the work done is positive or negative. Okay, so work done is positive when the force and the displacement are in the same direction, or in other words, when they are parallel to each other. When the force or the displacement are parallel to each other, they are then the work done is positive. Now, if the work done is negative, so when is the work done negative? Work done is negative when the force applied and the displacement are in opposite direction. In other words, they are anti-parallel. That means they are in opposite direction, 180 degree. So basically, you will find the angle between the force and the displacement direction, and that will give you cos 180 degree. Like the work done is FD cos 180. So 180 cos 180 is negative 1. So you will get the answer in negative. So the work done will be negative. So another kind of situation could be like, you see, they can say that a stone is thrown upward, okay, and it goes to a certain height. So they can ask you, what is the work done by the force of gravity when the stone is moving upward while it is in flight. So in that you can see that the stone is moving upward, so the displacement is upward, but the force of gravity is downward, right? So the upward motion, displacement up, force of gravity down. So the angle between the direction of gravity and the direction of the upward movement of the stone, that is 180 degrees. So you will have again cos 180 is equal to negative of 1. So the work done will be negative. Okay, then let us look at the eighth question. Eighth point here: determine graphically the work done by a force uh, from the area of force versus displacement graph. So in the force versus displacement graph, like you will have the force on the y-axis and the displacement of the object on which the force is acting on the x-axis. Okay, displacement on the x-axis, force on the y-axis. So what happens here is that you could get several shapes. One could be like, it could be a right angle triangle, like the area of the force, area under the graph of the force versus displacement graph will give you the work done. Okay, so the work done is equal to area under the graph. Now they can tell you like the displacement maybe on the x-axis, there will be several sections, right? The graph would be rising, then it could be constant, then again it will come down. So the line is when the line is rising, so you have to look at the read the question carefully in this and answer accordingly. Maybe they are asking only for the force, only for the work done from a particular position to a particular position. So you have to find the area only from that position to the other position. Okay, so that's one kind of question they could ask. So so you should remember the formula for trapezium. You should remember the formula for area of a rectangle, area of a trapezium, area of a right angle triangle. So any three of this can be used in this question. So you should remember that. And I don't think they will give you the formula for the areas in the physics exam, because it's a math concept. So just be careful. Just I would advise you to memorize the formula for uh, area of a trapezium, area of a rectangle, area of a square, and area of a right angle triangle. Okay, so that's the eighth one. Okay, now let us go to the ninth question, which is apply the relationship between power, the work done by a force, and the time interval in which the work is done. Okay, so in this question, you see we will directly use the work done. So power is equal to work done divided by the time it took to do the work, right? Work done divided by time. So you will use this relationship to find. So you have to read the question carefully and try to find out what is given. So you maybe the work done may not be directly given, right? So you have to, maybe they will tell you that this is the force that is applied and this is the displacement, and this is the direction in which it is, angle between force and displacement. So you have to use the formula work done is equal to fd or fd cos theta, and you have to find the work done, and then you have to figure out what is the time given in the question, and you have to find out the work done divided by time taken, and that will be equal to the power. Okay, so this is a straightforward question application of the formula. Now let us come to question number 10, which is the rotational kinetic energy. So rotational kinetic energy, you will use this formula which is given. Rotational kinetic energy is equal to half I omega square. Now here I is the moment of inertia. Okay, moment of inertia is like, for anything which is rotating, it is like the mass in the normal straight line motion, in the rectilinear straight line motion of an object. The mass, uh, mass is used in the formula half mv square, right? So half mv square, so m is the mass, so it is like, the more the mass, it's more difficult to push an object, speed up an object. So similarly, in the rotational kinetic energy, I is, the more the moment of inertia, it is more difficult to rotate the object. So this is this I. Now you will learn about I, or the moment of inertia, in grade 11, but all you need to remember is the moment of inertia can be calculated by a simple formula, and you will be given a simple shape like a wheel or something, and it has a moment of inertia with the formula I is equal to mr square. M is the mass and r is the radius of the object. So the moment of inertia depends on the shape of the object and the mass of the object. So that is why it is I is equal to mr square. So you have to first calculate the I in this formula, and then you will also be given the angular velocity. Now the angular velocity is how much angle it sweeps in 1 second. So it's like angular speed, angular velocity. Okay, now angular velocity will be given in radians per second. That is the unit for angular velocity. So it will be given in radians per second. So you have to substitute the value for radians per second in the for the velocity, angular velocity, and you have to substitute in this, and you have to calculate the rotational kinetic energy. Now let us look at question number 11, which is the relate the gravitational potential energy to the mass of the object and its height above or below a reference level. Okay, so in this question, what we must be careful is we must read the question and first figure out what is the reference level that they are talking about. They will give you a specific level, reference level, from which you have to calculate the height of the object. Only then you will get the correct value for the gravitational potential energy. So gravitational potential energy is mass times uh, uh, gravitational field times the height. So when it's only the height which is going to trouble you, so you must know what is the reference level, and from the reference level how high or how below is the object, above or below. So this is the only thing which you should be careful about. Okay, then question number 12, they are saying apply the law of conservation of mechanical energy to solve problems. So in this, what happens is they could give you some situation like a roller coaster or something which is going up and down, uh, and they could ask you like, what is, they could give you the kinetic energy when the roller coaster is at a high, uh, they could give you the potential energy when it is at a high place, and as the roller coaster is moving downhill, it will increase in kinetic energy, and so on. So they will ask you something in which, what is the total mechanical energy at certain point. Okay, so they could give you the kinetic energy, and you have to find out what is the total mechanical energy. So as you see in a roller coaster, what happens, the kinetic energy will be high when it is at a height, and as it comes down, most of its kinetic energy will get converted into potential energy. So when it is at the lowest point, it will have only kinetic energy. From highest point, it has most potential energy. Then when it comes to the lowest point, it has only kinetic energy. And when it goes further to other another hill, again that potential energy gets converted to, again that kinetic energy gets converted to potential energy, and so on. So you have to find out at which point these energy transformation is happening between potential and kinetic. And as they will give you some data regarding how to figure out the mechanical energy. The mechanical energy is the total of kinetic and potential. So kinetic and potential energy, the total you have to find out, and from that you have to find the mechanical energy. And you have to also use the law of conservation of energy, because the energy is conserved, the mechanical energy will be the same throughout the motion. So that's the question. Then in question 13, kinetic energy and apply the relationship between particles kinetic energy, mass and speed. So in this question, what they could give you, they could give you the mass and the velocity, and they can ask you to find the kinetic energy using this formula. Another kind of question would be, they could give you the kinetic energy of the particle and the mass of the particle, and you have to find the velocity of the particle. So you have to rearrange this equation and find the velocity of the particle. Okay, so that's another kind of question that could be asked. Then in the question 14, they are asking, describe the relationship between the velocity of a fluid and the pressure it exerts according to the Bernoulli's principle. Okay, so what happens here is, you see the velocity of a fluid and a pressure is exerted according to the Bernoulli's principle. So in this, what they could give you a picture of a pipe with a few spouts coming out of it, like a tube which is coming out of the pipe. Okay, vertically. So they will say, they could give you a picture and they could say how to apply Bernoulli's principle. So if the pipe is narrow, the velocity of the fluid will be faster through that section of the pipe, and because of that, there will be faster velocity. Because of that, higher the velocity, the lower the pressure. That is what the Bernoulli principle says. So, so that means you can find the area. You can find the section of the pipe where the velocity is highest, and you can say that the pressure at that particular point is lowest. So they could ask you questions like, which at which point of the pipe the pressure is lowest or highest, or maybe like order ABC 1 2 3, how to order the velocity. Okay, then you have the Pascal's principle. So in the Pascal's principle, they could ask you, what is the statement. Okay, they could ask you to state the Pascal's principle. They could give you some statements and you have to select the correct one. And the second one, they can ask you apply Pascal's principles to hydraulic systems. So what is a hydraulic system? Hydraulic system is a system which consists of pistons and fluids. So hydraulic system is used in car workshops and garages to lift cars and heavy objects. So how does it work? You can lift objects which are very heavy by applying a small force. Okay, so that's the best thing about hydraulic system. That is the advantage. So how do you find it? How do you get it done? you can use the formula F1 over A1 is equal to F2 over A2. So in this formula, they will give you three pieces of information, something to find out A1, A2, and F1 or F2. So one of these four variables will be unknown. One of the four variables will be unknown. You will be given the other three. You have to rearrange the equation and find the unknown. That's all you have to do. Okay, then now let's move on to the free response question. So in this one, this question they are asking, apply the relationship between force and the work done on a system by the force when the system undergoes a displacement d. So work done is equal to Fd cos theta, where theta is the angle between the direction of force and the displacement. So this is a general case in which they could give you some object which is moving, and when it moves, the force and displacement are in two different directions. They are not parallel to each other, and they will give you the angle. So you have to find the work done. Okay, then using this work done, they could ask you find the velocity, the final velocity of the object. So there you will use the second part, apply the work energy theorem to relate the net work done on a system and the resulting change in kinetic energy. So work energy theorem says that the work done on a system is equal to the change in kinetic energy. So in the first section you will find the work done, and this work done is equal to the change in energy. And in this case they will say the kinetic energy, only the kinetic energy is changing. There is nothing, no mention about potential energy. So you will find the velocity of the object by rearranging the equation. Okay, now let's go to the 17th question. 17th question, it says apply the law of conservation of mechanical energy to solve problems Ki plus Pe is equal to Kef plus Pef. So apply the law of conservation of energy to examples like roller coasters, ski slopes, inclined planes, hills, and pendulum. So this is similar to what I was discussing earlier. So they could give you a situation in which they could give you some pictures with bar graph or bar graphs, or with pie charts or something, and they could ask you what is the total mechanical energy at certain point, or when is the maximum kinetic energy at this particular point throughout the motion, where is the kinetic energy maximum, where is the potential energy maximum, where is it lowest, and what is the total kinetic energy. Or maybe they will ask you to sketch a bar graph or a pie chart. So you have to draw or sketch a pie chart or a bar graph. So this is another kind of question they could ask. Okay, then in question number 18, they are saying like explain Kepler's first law, which states that the planets follow elliptical paths with the sun at one of the focus. Explain Kepler's second law, explain Kepler's third law, explain law of universal law of gravitation, and write its equation. So these are the same thing. So you should be thorough with the Kepler's laws, all the three Kepler's laws, how to apply Kepler's third law using this formula. T square is proportional to R cube. Okay, and another one is you must know how to explain the law of universal law of gravitation. So they could give you a small question to solve. Okay, then in the last one, they could ask you like calculate the orbital period of a satellite. So for the orbital period of a satellite, you if the mass of the planet is given, you will use the direct formula, okay, which is T is equal to 2 pi square root R cube over G, which is the universal gravitational constant, G times the mass of the planet. If the mass of the planet is given, that's the formula you will use. If the mass of the planet is not given, you will use Kepler's third law equation. Then the second part is the pressure as a perpendicular component of a force is divided by the area of the surface. Okay, so in the 19th question,